Hello everyone. This video is going to go through how to calculate the adiabatic flame temperature for ethane. Now we have ethane here. The combustion equation for ethane is C2H6, and that's combining with oxygen to produce these products of combustion. Now to calculate the adiabatic flame temperature, we can use equation 1.28 from page 27 of Drysdale's An Introduction to Phytodynamics, second edition, where TF adiabatic is equal to the ambient temperature plus the heat of combustion of the fuel divided by the sum of the number of products times their specific heats. So in this equation, TF adiabatic would be equal to, and let's assume that the ambient temperature is 298 Kelvin, and work this out in Kelvin, so that's 25 degrees Celsius approximately, plus the heat of combustion for ethane is 1423 times 10 to the third joules per mole, and so this term is divided by the sum of the number of moles of each of the products of combustion times that specific product's specific heat. So this should probably be defined as summed over I of N of I Cp of I if you wanted to write it in index notation. So that I've listed over here the specific heats and the number of moles for each of the reactants. So for CO2 we have 2 moles times a specific heat of 54.3 joules per mole Kelvin, and this is specific heat at constant volume, constant pressure, I got that wrong, constant pressure, plus 3 times 41.2 plus 13.16 times 32.7. Running out of space, okay. So you'll notice this, the nitrogen adds a significant amount of energy absorption to this particular equation. So TFAD comes out to be 2147.8 Kelvin. So, and this is pretty much the maximum temperature that you will see in a combustion reaction. So adiabatic means there's no heat losses. So if you were to do this in, let's say, in oxygen instead of air, you wouldn't have this heat absorption term here, and so you'd get a higher number. But in terms of ethane and air, this should be the maximum temperature you would ever see. So if you were doing, let's say, an experiment and you were measuring something higher than this, then you could infer that your instrumentation was somehow compromised, or you had a different fuel, or something was amiss. I hope you have found this video useful, and I hope you have a good day.